Good morning, ladies and gentlemen, and welcome back to this third and last day of our Global Space Exploration Conference, GLEX 2021. I know for those who are here, it was a tough evening yesterday, an outstanding gala dinner, and it's very early again this morning. So thank you very much for being with us for this morning session. This last day of the conference will still bring outstanding and very interesting sessions for all of you, so please stay tuned during the day. The first session is an exciting highlight lecture focusing on the UAE National Space Program, organized by the Mohammed bin Rashid Space Center. The lecture will introduce the various pillars of the UAE National Space Program, such as the Satellite Development Program, the Emirates Mars Mission, the UAE Astronaut Program, the Mars 2117 strategy, and finally, the Space Ventures Program. The session will present the current and future missions and projects under each pillar, and will focus on the new and ambitious initiatives announced recently by the UAE, such as the Emirates Lunar Mission and the UAE Analog Mission and Mars Science City. This session, by the way, comes with particular relevance as it serves as a kind of appetizer for all of you to the exciting and upcoming International Astronautical Congress, the IEC 2021, co-organized by the IEF and the Mohammed bin Rashid Space Center, and it will take place in Dubai from the 25th to the 29th of October this year. I should also say that for this session, you will also have the opportunity to engage with the speaker by asking questions and rating the questions through our Slido system, which you know already perfectly well now. It is now my great pleasure to give the word to Adnan Al-Rais, Senior Director of the Remote Sensing Department and Program Manager for the Mars 2117 strategy at the Mohammed bin Rashid Space Center. Let's give him a round of applause.
All right, thank you very much, Christian, for the introduction. Good morning, ladies and gentlemen. First of all, I'd like to thank you all for being here on the very last day of the GLEX conference in the first session. I would like also to thank the audience that we have and they're following us online. Before my presentation, I would like to also have special thanks to our host, Roscosmos, and the organizer, IAF, for organizing such a great event, in-person event, the first space event during this pandemic. As mentioned by Christian, we're also looking forward to having you all in Dubai for the IAC in October this year. So today in my presentation, I would like to give you a quick overview of the UAE National Space Program, talking about the current projects and initiatives that we have, as well as future missions and projects as part of the UAE National Space Program. The UAE National Space Program consists of 4 main programs. Let me see if the clicker works. It's the green one, right? All right, before we have the, okay, you can check from your end. So, oh yeah, here we are. So the UAE National Space Program consists of 4 main programs. Those are the 4 main pillars of our National Space Program. The first one is the Satellite Development Program. The second one, which is the Emirates Mars Mission and Mars Exploration. Thirdly, we have the Mars 2117, and the 4th program is the UAE Astronaut Program. In my presentation today, I will go through each program, talking about the projects and the initiatives that we have in order to implement those programs and take them to the next level. First of all, the Satellite Development Program. This is the first program that we started working on since the establishment of Mohammed bin Rashid Space Center back in 2006. Quick history, we did the technology know-how transfer program with South Korea Through that know-how transfer program, we developed our first satellite, Dubai Sat-1, and we launched it successfully in 2009. We continued that know-how transfer, and we did the joint development on the second mission, Dubai Sat-2, with our partner South Korea, SATRIC Initiative, and we launched the second mission, Dubai Sat-2, in 2013. After that, we reached a level that we can depend on our local Emirati engineers to work on the development of the follow-on mission, which is the Khalifa Sat, which was 100% developed by Emirati engineers in our facilities at Mohammed Barash Space Center in Dubai. Those are 3 Earth observation satellites that provide high-resolution imagery from Dubai Sat-1 that started 2.5 meter resolution to Dubai Sat-2 to 1 meter, Khalifa Sat, which is currently operational, that provides the 70 centimeter resolution. We have a strong team working at the center on the development of value-added products and advanced applications. We have developed our AI and deep learning capabilities to use our data integrated into our system, as well as other data sets from other satellites to develop valuable applications for our end users. When it comes to our end users, we have from government entities, environmental agencies, urban planning departments, and other agencies, as well as internationally. We provide our imageries to the nations affected by natural disasters through International Disaster Charter and Central Asia and other platforms. After the Khalifa Sat mission, we worked on the follow-on mission, which is the DM-Sat-1. It is UAE's first environmental satellite, fully dedicated for air quality monitoring. This is a satellite that was developed by Space Flight Lab at the University of Toronto. Our focus was mainly on the development of the algorithms for the different applications of the satellite. We successfully launched the satellite on the 22nd of March this year on Soyuz rocket with Fregat upper stage from Baikonur launch site. The unique thing about this mission is that we got the requirement from our municipality. So the municipality approached us to asking for how we can use a space segment in order to monitor air pollutions. So we worked with them on the development of the requirements of the specs of this mission, and we partnered with the Space Flight Lab to develop the mission. This mission has 3 main payloads onboarded. We have the polarimeter to monitor the air pollutions. It's the first time that we apply such concept on a small mission that's 15 kg. Usually it's applied on bigger missions. This polarimeter takes multiple observations of the same area at maximum 7 different angles and with 2 different polarizations. And using the different layers from the 3 different bands, we can detect the pollutants that could be found at the PM 2.5 and PM 10. Also, in addition to the polarimeter, we have 2 spectrometers that basically detecting the greenhouse gases, CO2, CH4, and the H2O concentration. This mission is very strategic for the country. As you know, the UAE signed the climate change agreement, and each country has a commitment to fulfill the requirements towards the climate change agreement. As a UAE, we have ground systems to monitor the air quality. We've added the space element so that we have the whole column information, creating that inventory to monitor the greenhouse gases and air pollutions, and share the data and the knowledge with other countries and other cities that could use this data. Also, continuing on the satellite development program, our follow-on mission when it comes to the Earth observation satellite is our next generation satellite, MBZ-SAT. This is a continuation of the Dubai Sat constellation. It's going to be another very high resolution optical payload, different category, more than 700 kilogram of satellite and mass, sorry. And we are planning to launch it in 2023. It will add value to the existing missions, as well as will have advanced applications that will be developed in particular for this mission, the MBZ-SAT. The team at the MBRC that we invested in for the past 15 years working on the development of this mission, as well as other missions that we'll talk about in the coming slides. Moving now to the second pillar of the UAE National Space Program, which is the Emirates Mars mission. As you know, the Emirates Mars mission, the HOPE probe, which was launched successfully July 2020 and reached its orbit February 9th, 2021. This is a mission which is basically part of international collaborations with the universities in the United States, working with the University of Colorado in Boulder, Arizona State University, and UC Berkeley, as well as other partners from other space agencies, research institutions, and universities, whether local and international, in different aspects of this mission. We had successful Mars orbit insertion. Currently, we are in the prime science operation phase. The main objective of this mission is basically to study the Martian atmosphere and provide this global, seasonal, diurnal, day-to-night coverage of the Martian atmosphere, and contributing, and complementing the existing missions around Mars and on the surface of Mars. This mission is funded by the UAE Space Agency, and Mohammed bin Rashid Space Center worked on the implementation along with our different partners. Here we have the different instruments. We have three main instruments on board this mission in order to achieve our goal to have that global coverage, day-to-night coverage of the Martian atmosphere. We have the Emirates Mars infrared spectrometer. We have the imager that works on the visible bands, and we have also the ultraviolet spectrometers. Those three instruments, with the orbit that we've selected, high elliptical orbit, will allow us to have that continuous coverage of the Martian atmosphere. Here we have some sample of the images and data sets gathered by the different instruments, the three instruments that we have on the HOPE mission. We have the team working on the development of the different levels of products, and that data sets will be available differently with the international space community. Moving on to the third pillar of the UAE National Space Program, which is the Mars 2117. Mars 2117 is our 100-year strategy to build settlement on Mars and sending humans to the surface of Mars. In order to do that, within the Mars 2117, we have four main pillars. The first one, the research and development. Under this pillar, we have a number of projects and initiatives and missions in order to develop the science and technologies that will enable us to reach the surface of Mars. We have education. Education is the key. It is really important that we have education outreach program to be an integral part of the overall strategy, so that we always prepare the next generations of engineers and scientists to contribute in this generational mission and strategy. Thirdly, we have enablement. With enablements, we focus here on building that space ecosystem, focusing on the institutions, universities, and research institutions to enable them so that they contribute significantly in our space missions, as well as building that industry that we don't really have strong industry today contributing in our mission. So we want to develop that industry, research institutions, also the whole ecosystem, including financial institutions that be able to finance such missions and finance such institutions working in the space sector and space industry. The fourth pillar in our strategy, which is the collaboration. International collaboration is an integral part in all of our programs, as mentioned earlier, through the Earth observation satellites, the Emirates Mars mission, and many other projects that we have. And we'll continue working with the international community and space agencies on the implementation of the Mars 2117 project strategy. So we always get questions. So what is your strategy? What are the main components? How are we going to implement it? Basically, as the UAE is part of ISEC and part of the international space community, we develop our strategy so that it's in alignment with the global exploration roadmap. So we don't have our different strategies. It's part of that global exploration roadmap. There are things in the global exploration roadmap. There are gaps in terms of the technology, in terms of the science. We are focusing on and contributing so that we contribute in the overall implementation and execution of the global exploration roadmap. So our strategy is in full alignment with the global exploration roadmap. Moon is our gateway to reach Mars in the long run, which is our our objective basically and the final goal to reach the surface of Mars and sending humans to the surface of Mars. So in order to do that, as part of Mars 2117 and in alignment with the Global Exploration Roadmap, we have introduced and launched a number of new projects and initiatives. The first one, we have announced our EMERS lunar mission and the lunar exploration. And our catalyst project is Rashid rover, a small rover that will be sent to the surface of the moon by 2022. We signed a contract with iSpace. The lander from iSpace will be hosting the Rashid rover. The strategic objective behind this mission is basically to develop our space robotics capabilities. It is our first robotics mission. With the previous missions, we've sent orbiters around Earth and Mars. This is going to be our first mission that will have a space robotics rover and space robotics mission on the surface of another celestial body, which is the moon in this case. We have a lot of unique science that will be conducted on the surface of the moon for the first time with the different instruments that we're going to have, like the Langmuir probes and the 3 different cameras that we have. And also we have an experiment called material adhesion determination experiment, in which we are going to have different types of materials between the grousers of the rover and seeing the interaction between the material and the surface of the moon. And taking observation from different cameras, we provide this information to our scientists and also our partners from different universities around the world to better understand the material on the surface of the moon and interaction with those materials. And this will help definitely in the future when you develop future missions to the surface of the moon or developing the astronaut suits and all of that. Secondly, so that is the robotics part. The human part is very important for us. And through the Mars 2117, we basically introducing the UAE Analog Program. Through the Analog Program, we're working on the development of our human research program. And we are very proud that we are partnering with our colleagues in IPMP and participating with them on the upcoming Sirius mission that will be from November this year for the next 8 months. Through the collaboration with our colleagues at IPMP, we have selected 5 research proposals with them. And for the first time, UAE research proposals and UAE PIs will be participating in an international analog mission. We are very excited about this mission and this collaboration. I would like also to take this opportunity to thank our colleagues in IPMP for giving us this opportunity to be part of this international analog mission. We are also having 2 candidates from UAE that will be hopefully participating in this mission, hopefully one of them participating in this mission and working very closely and preparing them. And we hope that we get the necessary approvals to include them in the upcoming analog mission. And it's going to be our first analog mission as part of multiple deployments and multiple analogs that we are planning to be part of different analogs as well with other space agencies that we're currently talking with. Moving now to also another initiative we're talking about. So that was part of the analog mission, the space robotics part of our R&D pillar in our Mars 2117. We have also the enablement, which basically building that space ecosystem. So we've introduced a program called the Space Ventures Program. And this program mainly focusing on the enabling our universities and also the startup entrepreneurs, as well as the existing industries to work on our missions, to develop the standards with the existing industries, to support them with our background and with our experience, as well as providing them our opportunities through different projects and missions that we have so that they can contribute in our projects. And we're very proud that we have established at least 3 or 4 new startups and space companies in the UAE in our Space Innovation Hub, which is part of our, we have a dedicated hub called the Space Innovation Hub in the Silicon Oasis in Dubai. And we have 4 companies established there, and they're working with us on the different missions that I mentioned earlier. And we're looking for more companies to be established, as well as attracting more international partners to work with us in our missions through our Space Innovation Hub. When it comes to the international collaboration pillar, we have also launched the World Space Sustainability Association. We founded the World Space Sustainability Association along with our partner ELSCO Insurance, as well as other partners that we have. The World Space Sustainability Association, it is the first space association based in the UAE, in Dubai. The topic of the space sustainability is a very important topic for us, as well as the UAE and international community working on different space missions. We have to be responsible in terms of the way that we develop our missions and making sure the sustainability of the space. Therefore, we have founded the World Space Sustainability Association. We're looking also for partners and members from different parts of the world to come with us and join this association to foster the space sustainability discussions, to promote the understanding of the space, the sustainability, and also to develop innovative ideas to mitigate the risk on space sustainability. Mars Science City is another program, another project falling under the Mars 2117 platform or strategy. This is going to be basically our platform where we're going to have our future space robotics labs, our future analog facilities, our habitat that we're planning to develop, our space sustainability lab, the World Space Sustainability Association. All those initiatives will be hosted in the Mars Science City. That will be in the city of Dubai. We are currently working on the development of the design of the Mars Science City. So for the next year, we're going to focus on that. And for the upcoming 2 years, we'll work on the construction. And hopefully, the Mars Science City will be ready and operational towards the end of 2024. As I mentioned, going to have state-of-the-art space robotics facilities, working as well with our partners on identifying the requirements for unique analog facilities as part of the Mars Science City. We work very closely with the international space community. We understand what exists, and also we are looking into the gaps when it comes to the development of the analog facilities. And working together with them, we're going to identify the requirements and the specifications, and most importantly, the different deployments that are going to be within the analog facilities that will be developed at Mars Science City. As well as the Space Sustainability Lab, which is the key, as mentioned earlier, with the World Space Sustainability Association, and also different research that we're going to have in the areas of ISRU, like, for example, the conversion of CO2 into polymer or glucose that will help astronauts in their long-duration missions to Mars. Finally, the UAE Astronaut Program. I won't go deep into this as it was introduced earlier the first day and the second day. As you know, we have launched our first astronaut International Space Station. We have the 2 astronauts, and one of them is the first female Arab astronaut. Those 4 astronauts, 2 of them are currently in Houston doing training there, and the other 2 will be joining them for training on future human space flights. So this was a quick overview about the Emirates, about the UAE National Space Program, the different programs that we have, and and the different initiatives that we have under those programs, and the different pillars of the Mars 217 and others, and how we are going to implement the UAE National Space Program in the coming years. Thank you all for listening, and I'll be more than happy to answer any question. I think we have less than 4 minutes for questions. So we have a couple of questions here from Slido. So the first one, what is the operational lifetime of the HOPE mission? So the HOPE mission designed so that it will operate 1 Martian year, which is 2 Earth years in orbit, and it could be extended for another 2 years. So we are currently in the prime phase of the science operation, and after that the team will decide on the extension or not. The second question, with regards to with whom are you partnering in Mars 2117 program? International collaboration, as I mentioned earlier, is an integral part in all of our programs and all of our projects. As I mentioned, we have many projects within the Mars 217. When it comes to the Emirates Lunar Mission and the Rashid rover, we are working with other space agencies. We are hosting payloads from other space agencies on the Rashid rover, and we're going to have announcement in the next couple of days on those space agencies that providing the payloads. We have also international space science community, part of our Emirates Lunar Mission. We are partnering on the analog program with IPMP, working with them on their Sirius mission. And of course, we're looking for future collaboration with them as well on the follow-on missions, as well as other analogs available. In general, we have partners from different parts of the world. And international collaboration, again, is an integral part of all of our programs and all of our projects. Since day one, we worked with South Korea on Earth observation satellites, and we did technology transfer. We worked with our colleagues in the Russian Federation on the launch of our satellite and the launch of our first astronaut. We worked with the United States and NASA on the support from DSM, for example, for our HOPE probe and the universities there. We have partnerships in Europe and different parts of the world. And we're going to continue doing that in all of our programs and missions. And, well, it's the same question that was introduced yesterday, that will UAE will be partnering with China and Russia on their International Lunar Research Station announced in GLEX 2021. We as the UAE, we're part of the international space community. And we work with everyone, basically. And if there are opportunities, why not? So we are open for collaboration with the whole international space community. As I mentioned, we are working with our colleagues in IPMP and in Roscosmos and different missions, and with the previous missions and the existing one. We're going to continue exploring different opportunities available. We basically, as a UAE, we don't have, since day one, our program and our projects were open, and we're continuing doing that and continuing this approach, basically. So what's the timeline for the Mars Science City? As I mentioned earlier, we have basically design phase, which is happening this year, and the next 2 years will be the construction, and towards the end of 2024, that will be the operation of the Mars Science City. I think by this reached the end of my time. Thank you very much all for joining me in this session.
Thank you very much, Adnan. I mean, it's really stunning to hear what you're all doing. Presenting this in 20 minutes was really a challenge, but it was really an outstanding presentation, summarizing all that. And we are, as I said, more than curious to bring the entire global space community to Dubai in October to learn more and see how you're proceeding. Thank you very much. I would like to leave you now with a few videos while we are setting up our next plenary, but please stay with us. There will be a very interesting plenary right after a short block of some videos. Thank you.